Hi, my name is Odd Christian Landmark. I work for a company called Greenbird. In that company, I work with the architecture and integrations, and that's what this presentation is about as well. It's about SoaML, modeling language standard for modeling services. And services, that's one way to implement integrations for the enterprise across your organization. It's about finding the right services and implementing those services in a good way. You need to model what the services should do and divide the responsibility between them. And in SoaML you have the support for those different activities. In this presentation I of course assume a service-oriented architecture, which means in short that I assume that applications consume services instead of integrating directly between themselves. So to put the modeling of services in the right perspective, we need to take a schematic look, an overview of a typical target architecture of an enterprise. In this view, I have illustrated the fact that a company or organization usually has a lot of applications or portals towards users, like customers or employees at the top in this picture. At the bottom you have the systems and databases that support the applications. So if we take a look at an application, a typical application, it could be a thick client or web portal. It would typically be designed with an object-oriented design style, with web components and application components. They will be designed and modeled before they are implemented, and for this UML is perfect. You have class diagrams, sequence diagrams, etc., and they are well established within object-oriented application design. The same goes for databases. And for databases, you would use static diagrams to design entities, and the UML modeling language captures the details you need both for relational and object-oriented database. So what we have not covered yet is what happens between the front-end applications and the back-end systems, more precisely the integrations between the applications and systems, or even better, the services between the applications and systems. So let's have a look at examples of what I talk about when I say services. You could say that you have a customer service handling registration of customer, etc., typically initiated by a customer portal, but also affecting CRM system and other systems. Maybe getting information from an address registry or something. You could have an account service with the customer accounts, relevant for subscription handling and initiation of bank transactions, maybe. And this will of course affect several backend systems as well. You may have a product service, which is dependent on product databases for retrieving information, maybe on behalf of customer portals, and it may be integrated with third parties. And then you could have an order service for order handling, billing, etc. This would use many other services. Calling it an order service would typically lead to updates or retrieving information from customer systems, account systems, etc. And for this it would use all the other services. So let's have a look at the typical scenario, an example of what we could use SoaML for. And for that, let's start with a typical source of service needs, which is a new business process. And here we have a very simplistic ordering process. Just for the sake of this example, we could call it an order process or a purchasing process. And we assume that the process will be implemented for a purchasing portal, where the customers who are supposed to buy the products are the users. We also assume that the portal, being a portal, does not itself handle business logic or data. So this process does customer, it handles that the customer chooses products, placing an order, billing an order, etc. And based on these activities in a process, it is apparent that we need some capabilities, some business capabilities, which could be translated into maybe services at one point. So we may need product handling, ordering, billing. So the portal can't fix this by itself. So it is dependent on some services to connect the portal to the capabilities of the rest of the IT portfolio, relevant for ordering, billing, and products. So let's have a look at the order service. So here I have given some examples of capabilities. And this is where we start to use SoaML models, finally. The point here is not to design perfect process solution, of course, but to show how we move from business needs to service identification, then to service design, etc. So, capabilities. It is quite intuitive that we need something we could call capabilities in order to fulfill the needs of a business process. More to the point, we need a purchasing capability, which is here covered by the customer portal. The purchasing process, is dependent on a product ordering capability, which covers the essential tasks in the process outlined above, from a customer perspective, that is. Adding products to the purchase, confirming order, confirming delivery of products. And for the product ordering to work, something or someone has to provide product reservation, and something or someone has to provide billing of the order as well. So what we are doing now is to identify service candidates. Hence we need to define some service interfaces that the process or application can consume. Still on a quite abstract level. The mentioned capabilities and the relations between them imply these interfaces you see at the bottom: reserve product, order product, and bill order. These interfaces are what we think we need, hence the notion of a service candidate. To take this further, we need to see all these interfaces together and begin to divide responsibility between what we call participants. In a services architecture model, we define participants that do some work and the service contracts between them. At this stage, one might find reasons to define a set of service contracts that are slightly different from the identified service interface candidates. But for simplicity, we have a one-to-one mapping between the contracts here and the interfaces defined above. So we're going to take a closer look at the service contract called order product at the left. In order product, we have a participant called buyer, which is the consumer, and an order handler, which is the provider. The contract is modeled with the roles involved. A buyer is the consuming role, and the handler is the providing role. These roles are generic, but in the current case, the handler role is filled by the order handler participant. We also define what the handler must provide for this contract to work. The responsibilities for the handler is here to provide adding products, placing order, confirming order, and confirming delivery. The responsibilities is what should be exposed through the identified service interface order product. So we're now in the process of detailing what this service interface should expose. The next step is to look at the interaction between the roles, buyer and handler, in order to see how the different tasks can be divided into different logical services, because we are still on a conceptual level. Here we see that the buyer adds products to the order and gets a confirmation back that those products are available. There's also placing of orders, confirmations, and the appropriate answers back from the handler. It is quite obvious that this might result in several services. So then we use the service contract and the roles involved with that to define some service points that the order handler participant provides. We call these service points order product, confirm order, confirm delivery, etc. the buyer participant consume the services with what we call request points. This is therefore the logical design of how the service contract called order product should be implemented. For physical services, this might mean different things. You can have one component called order handler that would expose 4 different services. Or you can have order handler as one big service with 4 different operations. Or you can say that you have 4 different services. You have order product service, confirm order service, and confirm delivery service, and so on. And for every example, of course, the services would be dependent on integrating with a bunch of backend systems. And that may be done through several other services, of course. So let's keep at this logical abstraction level, but look at a wider set of services. And we have a purchasing process, the one we have already looked at. The order service and the product service, a warehouse service, and the billing service. What's very important to keep in mind here is the link to the services architecture, the order handling architecture that we have presented already. This participant diagram shows the participants and service points between them, and they adhere to the participant roles and service contracts defined in the services architecture called order handling. In this static view of the services, we define each service to be a participant, and some of them are providing or exposing several service operations or service points. So that's not maybe an example of best practice service design, which in my opinion would imply one operation per service, which means that if one participant was one service, then we do have only one service point for that participant. I do want to show though several ways of designing the collection of services within the standards of SoaML to show that SoaML can be used in different ways. This diagram shows the dependencies between the participants, hence the dependencies between the services, and also the dependencies between the services and the purchase process to the left. This is a static view, but we also have the dynamic view. The dynamic view of the same services or participants we show in an activity diagram, which is a diagram type that is standard UML, so it's not SoaML specific, but it gets a new mission within SoaML, because this diagram shows the flow of control between the processes and the services. It looks a lot like BPMN, especially here, since I have omitted some activity diagram specific notations, but it is more suited for showing the interactions and flow sequence between a process, an application, and all the services these depend upon. Another important aspect of the activity diagram is to capture the information that flows from one service to another at a particular time, which you can see here. You have the purchase product activity in the purchase process, and you have place order activity in the order service. And that link must adhere to the service contract we looked at earlier, the service contract we called order product. And this contract is the one we defined with the buyer and the handler, the service interface, and we also define the message types for this contract, what kind of information that can flow between the services. So in short, it is important to keep the links and the relations, the traceability, all the way from business process through service capabilities, through service contract definitions, and in static participant relations and service dynamic behavior. If all the models relate to each other in a consistent way, you are certain that you are actually designing a set of services that gets the job done, and in this context makes it possible to implement the purchasing products in the right way. So now we are familiar with some important aspects of the SoaML standard, And now we can take a look at how SoaML models could be used in different integration scenarios. First, let's have a look at point-to-point integration. Here we assume no ESB, no centralized SOA platform, no central business process engine, and so we have no loose couplings. So the web shop would call the product system, and then you would have service contracts needed between those two systems for product information and product reservation. And if you look at the participant diagram, it shows the web shop system consume various services exposed by the product system. Illustrated by the participant to the right, the product system, exposing 2 service points, and the web shop system participant with its 2 request points, consuming the product system services. And then we move on to what we have been looking at earlier, which is service integration. This is where we have omitted the systems, because this is from the purchase process or the order process perspective. So the product service will, through the underlying services, take care of the integrations toward the product systems, but we haven't shown that here. If we move on to information service integration, it's equivalent to the previous example, but illustrating the fact that different participants can reuse a service providing a particular kind of information. Here you have the get product service, which is used by both the purchase process and the order process. And also shown here, the product service, which probably would be implemented as a set of layered physical services, deals with the reads and updates towards the inventory system, where product data resides. And then we have another typical SOA scenario, a portal integration, where a web portal aggregates various types of information and presented in a single view for a particular user group. Customer administration could be one scenario for a portal, and it would be dependent on customer registration, customer account administration, and address information. And this means that we need service interfaces for registering customers, adding accounts, updating addresses, etc. So this means that the customer portal will consume different services for each of these tasks. So now I have shown you different ways of going from business needs to logical services within the SOA modeling language, and I've given examples within different integration scenarios. The final thing I want to say a few words about is a typical service lifecycle. You have more phases in a service lifecycle than what I've shown here, but 3 important ones are service identification, where you go from maybe a business process to finding candidates for the services you might want to implement. Then you go to service specification, where you want to define the contracts that between the service consumer and provider. And then you go to service design, where you model how the services would fit together, and also the details within the services. So if we take a look at service identification first, that was the first activity we did. We found the capabilities, and we got an outline of the service interfaces we wanted. Then moving on to service specification, where we focus on the contracts. We are introducing the participants, we define contracts, how their roles in the contracts would interact. And then when you go to service design, we are more specific about which participants will provide the services. A participant could be a system providing services, it could be a component providing services, it could be a big service providing several operations, etc. And always linking that to the services architecture. Within service design, you would also need to provide some activity diagrams to show the interaction on a detail level between the participants. Now we have looked at a lot of examples of how we could use SoaML down to a logical level. When you start with more details within each participant, you would meet a lot of new challenges, of course, but I will leave that to a later session. So thanks for now. Thanks for listening. Thanks for watching. And if you want more information about SoaML, take a look at this address. And goodbye for now.